Okay, now we are going to do tan theta. Okay, what is tan theta? Let's say we have a triangle again. There is some angle theta. We draw up a perpendicular and get rid of this. Let's say this is my L, this is my B, the base, and this is my hypotenuse. So tan theta is basically the height L over the base. L over B. Now you can, to figure out how the graph of tan theta looks like as you vary theta, you can again try imagining what happens if you increase or decrease theta and what happens to L and B. Okay, we can do that, but instead of doing that, because we already have this, we're going to use these two curves. How? We know that sine theta equals L over H and cos theta equals B over H, right? So if you divide sine theta over cos theta, if we divide sine theta by cos theta, we get this, right? So we can get rid of the H, so we end up with L over B. That is nothing but tan theta. So tan theta is basically sine theta over cos theta. So, and we have the plots of sine theta and cos theta. We are just gonna use these two. This is equals to sine theta over cos theta, right? Now, I'll try to plot it on the same axis. That's fine. Okay, so sine theta over cos theta. When theta is 0, the red one is cos theta, black one is sine theta. When theta is 0, when sine theta is 0, cos theta is 1. So 0 over 1 will give me 0. This is my new x-axis. So 0 over 1 will give me 0. Now interesting is, when theta is approaching 90, what happens? When theta is close to 90, you see that cos theta is 0, but sine theta is 1. Cos theta is 0, sine theta is 1. You cannot divide something with 0, right? But you can go close to 90 degree. When you are close to 90 degree, your cos theta, the red one, is close to 0, or it has a small positive value. Let's say you are approaching 90 degree, your cos theta approaches 0, or it has a very small positive value, let's say 0.00001 or something, and your sine theta approaches 1, let's say 0.9999 something. What would that be if you divide them? If you divide 0.999999 by 0.00001, you will get a very big number. You are dividing something like 0.99 with 0.01, you will get a very big number. So as theta approaches 90, your tan theta goes to a very big number. So somewhere near the infinity, positive infinity. You will have something like, let's not use the different color. You will have something like this, where if you go closer to 90, your tan theta will just blow up to a very big value. Okay. More interesting is what happens if you just cross 90. If your theta is just slightly more than 90, so then your cos theta becomes negative, as we discussed. Cos theta is now negative, and it has a small value. It's still close to 0, but it is negative. And your sine theta is still approaching 1. It's still close to 1. So if you approach 90 degree from a larger angle, your cos theta is approaching 0 from a negative value, and your sine theta is approaching 1 from a positive value. Okay, so again it's the scenario where your sine theta is like 0.99 something, but your cos theta is now minus 0.01. But you are dividing something close to 1 with a very small negative value. So again, the result will be a very large value, but because it's negative now, the denominator is negative, you're going to have a very large negative value. So the moment you cross theta 90 degree, this is 90 degree, tan theta will have a very large value but negative. So you'll have something like this. So there will be a discontinuity at theta equals 90 degree. It will asymptote towards infinity. Now what happens at 180 degree? 180 degree, you see that your sin theta, black one, is 0, cos theta is minus 1. So 0 over minus 1, 0. So it will go to 0. This thing will keep repeating. You can do it as an exercise. Like this, again an asymptote, and like this. Like this. Like this. It will keep going. Like this. This. That is your tan theta.